Yeah, I think this is gonna be good. Gonna code, debug, and have fun. Coding with Radu. Coding with Radu. Gonna prototype and design. Coding with Radu. Coding with Radu. Let's code now. We begin with basic HTML. In the body, I'm gonna use a canvas element. We will use it to do the image processing part. And I'm also gonna add the video element this time, because I want to teach you how exactly we put this video on the canvas. You'll see. Now, if I'm gonna save this file and refresh the page, then nothing really happens. But here in the elements, they are there, this canvas and the video element. We just can't see them yet. So I'm gonna add the head section in our document where I'm going to link to an external CSS file like this. So I'm gonna need to create this CSS file by pressing here and typing style.css. Now in this file, I'm going to add a border for my video element, 4-pixel solid red border like this. And I'm just going to copy this for my canvas as well and make that one blue to know which is which. I'm also gonna remove the margin of the body. This margin right here, the orange part of the screen, I just don't like it. And set the background color to black. Now I refresh the page and we get this. So the items are clearly visible now. For the JavaScript, I'm gonna go back to this HTML page and I'm actually going to type a little bit of JavaScript right here. It's just to connect to the media devices. I want to access to my webcam, and then the effect is going to be implemented in some other file. You'll see. So here we write navigator media devices get user media. We call this get user media function, and we tell it that we want to get access to the video. We don't need the audio for this effect. Then, so get user media returns a promise, and we use then to pass a callback function when this promise is successful. We pass a function that gets this raw data as a parameter, and we will set this raw data as the video source, like this, and we start the video by calling play. Now, it's good to write here also a catch clause so that if we have an error, we will print it on the screen. I will just alert it here in case you don't have a webcam or something like that. Now, if I refresh the page and allow the camera, then I get this video feed right here at the bottom, and it adapts to whatever the resolution coming from my camera is. In this case, 640 by 480. The extra 8 pixels there are from the margin. Now we want to put this image on the canvas as well. The canvas up here, because the canvas has the methods that we can use for image processing. So I'm gonna go here and say that when the data is loaded, I will pass a callback function to this event, like this, and I will use the canvas context. We get the context like so. I will use this CTX to draw an image on the canvas, and I can just pass here my video as the image. It actually works. This video image will span from 0, 0, the top left corner of the canvas, and let me just write these here, my canvas width, my canvas height. I want the image to be the full size of the canvas. Now save the file, refresh the page, and you can see my image appearing there. It's a little bit squished because it wants to fit inside of this default canvas size, and it's not moving because it only prints there the first image it gets when the video is initialized. So we need to fix these things. I'm going to go up here and say my canvas width is equal to the video width, and the same for the canvas height. So I'm basically making the canvas the same size as the video. And now you can see they are having the same size, but it's still not moving. It's a static image for now. I'm not going to fix this problem right here. Instead, we start to work with external files next and implement our visual effect. So I'm gonna actually remove this code. We used it for debugging. And I'm going to re-implement it inside of the effect class. So we will write here a new effect on the canvas from the video, like so. We will write this effect class in a separate file, and we will include this file here like this in the HTML page. Let's create the file effect.js, and in here we begin to implement our effect class. And the class effect, in the constructor, we are passing the canvas and the video like this. And I'm going to store these as attributes of this object, like so. And I'm also going to store here a reference for the canvas context for quick access. So this CTX is canvas get context 2D. Now, to make this effect update on every frame, we will begin an animation loop. So let's call here this animate method. It's a method we will implement next. And I'm using this hashtag right here because I want the method to be private. Only this object can call this method. So our animate method is going to be doing something pretty similar as before. I'm going to get an access to our context canvas and video here from this object. I just don't want to type this.ctx, this.canvas, this.video everywhere. So I'm using this object destructuring syntax right here. And now, the same as we did before, I'm going to call ctx draw image, the video, from 0, 0 to the canvas width, canvas height, like so. And to loop, we need to call request animation frame and pass this animate method as a parameter. But there's one more thing that we need to remember here, and that is that this object still needs to refer to the effect itself. We do that by typing here bind this. We are essentially telling the animate function to remember this as the effect. I close now the animate method and the effect class, save the file, refresh the page, and this is the canvas that is animated now. The video is here at the bottom. They are pretty much identical at the moment and exactly what we need. And since we'll be doing the image processing on the canvas alone, the video can actually be hidden if you want, like display none, like this. So now the page only has the canvas element there, or even removed entirely from the DOM, which is what I usually do in my videos. So by that I mean that here in index HTML, I don't need to add this video there at all. I could just write here const is equal to document create element video like this. And this is still going to work when I refresh the page. But there is no video element to be found, so it's just in memory in JavaScript. Let's also make this canvas so that it spans on the full screen. Let's set its width to 100%, for example. So now I see the full feed coming from this camera in front of me. And I don't like this scroll bar right here, so I'm gonna set overflow to hidden for the body in CSS. So let's just put here overflow hidden. And my canvas, I don't think we need the border anymore. Just a width of 100%, and we don't need this video anymore. I just used it for teaching. Refresh the page, and now the canvas is the only thing on the page spanning the full page right here. So let's start analyzing the data coming from the camera here. I'm going to go into this effect. And after we draw the image on the canvas, we can take this image data using the getImageData method of the canvas context. And I'm gonna just specify here the full image data. So starting at the 0, 0 top left corner to canvas width, canvas height, like so. And let's log this image data in the console for now, and I'm gonna write here debugger so that the execution pauses at this stage. Now, if I refresh, we can see that the code has stopped at this debugger right here, and the console shows the image data object right here. It shows it's an image of 640 by 480 in the sRGB color space, and if you open this, you'll notice this data array with 1 million something elements. This number is actually 480 times 640 times 4, because the elements in this array are groups of 4. We have a component for red, green, blue, and alpha, the transparency of each pixel, and then it repeats with red, green, blue, alpha again, and so on. This is a very long array. And the pixels are in order from the top left part of the screen going towards the right and then row by row downwards. So this is the value of this pixel on the top left corner, which is green right now. But if I'm gonna take this blue marker right here and I'm going to go to the sources and press this play button so that I get new images from the camera every time I press play. And if I move this blue marker in this corner right here, like so, then if I go to the console and I check these new prints here, I clicked quite many times trying to get the marker in the right position, and analyze this image data, we should see the first pixel having a lot of blue and some green, no red at all. So this corresponds to the color of the marker. It's not a perfect blue, but we'll get to that later. And the transparency is 255 for all the pixels. My camera doesn't support transparency. Okay, so I don't need to debug anymore. I'm gonna remove these lines of code from here. And what I want to do is get the blue pixel locations. We do that by typing here locks is equal to a function that we will need to implement in a second, where we pass this image data as the first parameter and then the color that we are looking for. And I'm gonna put here pure blue for now. Now, to debug if this will work, I will also quickly write here some code that draws these identified locations using yellow color. So going through all of these blue pixels, pretty much, I want to draw a small rectangle at their location. and a small rectangle, like just a square, 1 by 1 square, like a pixel. And I will fill this with the yellow color. Now let's implement this getLocationsWithColor function. And this is a general function. I'm going to put it in a file I call utils.js here. And let's not forget to include it as well in the HTML file. So how does this function look like? Well, the parameters that I'm going to pass are the image data and the color that we are looking for. And the thing that it will return are these locations, which we'll store in an array. The array is empty for now, but we're going to go through the image data and add pixel locations where they match this given color. So we can iterate through this data by going through this image data object, like so. And I increase here I by 4 at each step because I want to jump from group to group with one iteration. So inside of this, I'm going to get the pixel color. Let's say p color is equal to, and I will make an object here with r is equal to image data of I. So this is the first element there in the group, and then the second element was the green, and the third element is the blue. And I'm just going to ignore the transparency, the alpha component. I don't need it in this project. Now, this is the RGB, the color of the pixel, but what we really want to find out is the X and Y in the grid. So the first thing we need to get is the pixel index. And that's easy. It just comes from I by dividing it by 4. And because we're increasing here by 4 at each step, we know that this is divisible, so we don't need to do any kind of flooring or anything like that. Now, for the X and Y, I want to explain this on a smaller image so you can see the pixels. This one is just too many of them. So I'll make it small and pixelated so that you can see each individual pixel. And this is P index in the beginning, in the top left corner. And it grows towards the right as we reach the width of the image, in this case 32 pixels. And then it continues to grow actually as we go on the second row towards the end, and so on. So the question is, what's going to be the X and Y of this particular location there, knowing the P index? And it's not very hard. We just have to divide by the width of the image. In this case, we get 5 with a remainder of 7. So our pixel's location is 7 and 5. Let me just implement this in code and say that the location is going to be equal to, for the X, I take P index modulo the image data width. And for the Y, I'm going to use the floor function to get an integer. And right here, P index divided by image data dot width. Like so. And the next part, we really want to store these locations only if they match the given color, the one up here. So we will have to write something like, if there's a color match between P color, the color of this pixel, and the given color, the one that we are looking for, we add this location to the array of locations. We can close the for loop now, and I'm going to return all locations and close this function. Now, this color match function, I'm just going to implement a quick one right here, where given two colors, C1 and C2, I just check if they have the same red component and the same green component and the same blue component. We return true, the same color. Otherwise, I'm gonna return false. Now, if we save this and refresh the page, it doesn't actually work. I mean, we were supposed to get the blue pixels recolored as yellow for our debugging right here, but it doesn't work. And the reason for that is this color match function. It's too strict. You remember before, it wasn't the pure blue color that we were seeing in the image data in the console. It was something else. And if we think about colors in RGB space, where red is this axis and green is this axis and blue is this axis, we can calculate a distance from this pure blue color right here to any given color pretty much. So we can calculate this distance and say that if the distance is less than a threshold, we accept this as a positive match. Now, to implement this distance function, I'm just going to type it here in the utils file, like so. And this is the Euclidean distance between 2 points, but I'm going to use the RGB color components as the XYZ. So I'll write here the square root of the difference on R squared plus the difference on G squared plus the difference on blue squared. Like so. This is the formula for the distance between 2 points in Euclidean space. It's essentially the length of the diagonal of this cuboid right here. You can figure out this formula by applying the Pythagorean theorem twice. Okay, so what we do with this is we consider a threshold here in the color match function, let's say equal to something like 160 works in my room. And here, instead of this, we will write distance between C1 and C2 is less than the threshold. And actually, you can write this more neatly, like so. If you just return here whatever the result of this comparison is. Now, if we refresh the page, you can see these pixels marked using yellow, just the way we want it. And I don't think we need this other camera anymore. I'm gonna focus on this one right here. And one more thing, this square root right here is not really needed. I've made a video about why using a square root is not very efficient. And we can fix this by calculating here the distance squared instead and squaring the threshold. So if we calculate the squared distance, let's just write here the squared distance without the square root, essentially just leaving it as such, it's essentially the same thing. So the code works and it's more efficient in this way. And if you want to still have a distance function, the Euclidean distance between 2 points, it can be quite useful. You can write it here by calling the square distance function between C1 and C2, but applying the square root on this instead. So it's a little bit slow because we are moving this code in another function, but it's clean and I like it like this. So let's refresh this page and everything should still work as before, but this is much faster now. And it is important because remember, all these pixels in the image, all the 300,000 something pixels in this image are being compared to that blue color we give as a reference. So there are like 300,000 comparisons using this square distance function now on each frame. And yeah, this distance function is not used, is get the center of mass of all these yellow pixels right here. So I'm gonna go in the effect.js file and here let's write some code that goes like this. If we have locations, So if we have at least one yellow pixel there, then we can get its center of mass, but we will most likely have a lot of them. Then I'm gonna write center is equal to the average of all locations. And this average function is something we need to implement next. But let me just display this as a red circle on the screen. So fill style set to red, and then arc at the center X, center Y, using 5 pixels as the circle radius, and the full circle between 0 and math pi times 2 radians. So let's fill this and go to utils.js and implement our average function. So the average of an array of locations is going to be this result right here, which I initialize as 0, 0. And then I will say here I'm going to add its x component to this result and its y component to this result. This is the sum of all x's and y's. I still need to divide this sum by the number of locations to get the average. And I do it for x and for y and return result. Okay, now if I save, refresh, you can see this red dot right there in the middle of all the blue locations. Let me go back to effect.js and remove this debugging code. Like, I don't really need to emphasize the yellow pixels anymore. And this red, I'm quite sure it works. Now, this center right here is the location where I want the pinwheel to be. Let's move to that next. And I'm going to go here in the constructor and define at the top, this pinwheel is equal to new pinwheel. It's not going to have parameters here because we don't know where to put the pinwheel before we have this center location, before the marker is on screen. It may not be on screen in the beginning. But after it is, we can update the pinwheel with this new information. And 2 things are needed. The center, yeah, but also the size. I want it to appear larger when it's closer to the camera. So when there are more identified pixels on the screen, if that makes sense. So let's see. I'm gonna write here the size of the pinwheel is equal to the number of locations. For now, we're gonna have to play with that a little bit. But then the pinwheel update with the context at the center and of this given size. This pinwheel is something we need to create next. I'm gonna go in index.html and write here pinwheel.js and create the file pinwheel.js like this, where we write our class. So the pinwheel constructor is going to be empty here, no parameters, but we will have some attributes that the object will need, like x, y, and the size. I just put these to null so that we know they are going to be appearing there. Then the update method. So we will update using a context at this center location and with the size. And we set here x is equal to center x, y is equal to center y, and size is equal to size. And let's proceed to draw a pinwheel. And I'll focus on this orange part first. So to make things easier, I want to translate the canvas to that center location. And I do that by writing here save and then translate to this x and this y. And now 0, 0 means here in the center point. From here, we can now begin a path and say move to that center point. and do align to at the top. So if the size of the pinwheel will be this value right here, then that top part is going to be at 0 and minus this size divided by 2. Remember, y goes positive downwards on a computer. Then align to this point right here, a quarter of the size to the right and to the top, and line to this size divided by 4 and 0. So this is this other point right here. And finally, I want to close the path, which will make a line to the starting place in the origin. Let's set the fill style to orange. Fill. Also stroke, I want to see the line as well. Default color black is just fine. And restore the canvas context. Every time we do these kind of translations, it's very important to remember to restore. Otherwise, when we draw the next thing, it's going to be translated somewhere we don't want it to be. So let me now close these, save, and refresh the page. And we get something there, but the size is not quite right. I mean, it's really small here in the back, but as I get this closer, it really grows a lot. And that's because we are sending here the number of pixels as the size, which you can think of as the area somewhat. And we really want to know somehow the length of whatever the shape is. Area is when you multiply two lengths together and then you get kind of a square value. It's too much. So to get a value that looks good, we're going to need to do a square root here. Math.sqrt of this location length. And this should scale much nicer now. If we refresh the page, you can see a very small part there, but it's consistent in size with the marker because we are using this square root function there. So I can scale this, no problem, make it a little bit bigger, like maybe 5. This will control the size of the pinwheel, and I don't want to add the parameter for that. You can do it, you should, but I think it's overkill for this project. And this is much better now. Yeah, I think it's a good size. So next what I want to do is export this code right here, separate it into a function, because I'm going to reuse it to draw all the other parts as well, the other 3 parts. Important thing there is the different color and a different angle, a different rotation for each part. But otherwise the code is the same. So I'm going to remove the code from here into a private method called draw part, like a single part, on a given context with a given color at a given angle, like this. Now here, I'm gonna paste this code like this and make sure that I pass the color here, like this. And this angle, I'm gonna use a trick and simply do ctx rotate at this angle. So with this draw part method now available here in the update, I'm gonna say this dot draw part on the context with the color orange and 0 angle. That's what we had so far, but we can copy this 3 more times and put here, for example, math.pi divided by 2, because I want to rotate by 90 degrees, and then math pi, I want to rotate by 180 degrees, and 270 or other direction minus math pi by 2, other direction 90 degrees. So this is gonna probably work. Let's see, refresh. Yeah, it works just fine. But also different colors, and I found this color choice to be pleasing. Pink for this one, then sky blue and sea green. Yeah, this is nice. But it's boring, it's not spinning. And that's what we're gonna do next. We're gonna add here at the top in the constructor two more attributes for the angle and for the speed, how fast it's spinning. So let's put here speed is 0 by default and the angle also 0 by default. But then here, before we change the size, I want to use the old size as the reference. So if the size is increasing, I want it to spin in one direction. If the size is decreasing, I want it to spin the other direction, uh, or push it a little bit in the other direction. Let's see. So if we have a size given, because it's possible here to be the first time we call update and then we can't do the relative difference to the previous size. We don't have anything to compare with. So we need to have at least the previous frame where the object existed. Then we calculate here the difference equal to size minus this size. So size here is this parameter and refers to the new size that the object is going to be, the next line here. And with this difference, I'm going to calculate a push. How much do we want to push the pinwheel? And it's going to be difference multiplied by this value, which I found it looks really nice. You can play with this to make it spin faster or slower. So this difference is going to be positive or negative, and this push is going to be positive or negative, and it's going to impact the speed at which the pinwheel is moving. The angle of the pinwheel, we set it here, increasing it by the value of the speed, which again can become positive or negative depending on the direction we are going to be moving the marker towards the camera or backwards. And I also want to add this line here for dampening the speed. Otherwise, once it's moving, it will never stop. And that's not realistic. So I'm going to have to do that if I want the pinwheel to stop. And the last thing is this angle that we are now calculating here needs to be added to each of these offsets at the right. So 0, just replace it with this angle, but here we add this angle with math_pi divided by 2 and then with math_pi, and here we subtract math_pi divided by 2 from it. So we save the file, refresh the page. So a lot of things happening with quite a little bit of code. You can see the pinwheel is stopping if I don't move the marker closer or farther away. Like I can move it side to side without much movement, but if I move it closer, it's really gonna start to spin like the air is pushing it. And some pinwheels also spin in reverse, so I don't think it's a thing really, but I wanted to do it here. I think it looks special. So yeah, thanks for watching and see you guys.